Welcome to Do the Math America. I am Charlene, Math Shaman. Today we work on prime factorization out of the beginning algebra book, pages 47 and 48. Please look in the description box below this video for the PDF file of this book. Please make a hard copy of this book for yourself. It is out of print and not available for purchase otherwise. Prime factorization. A prime number, a whole number other than 0 and 1, which is divisible only by 1 and itself. Here are the prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, etc. A prime number has exactly two factors, 1 and itself. 0 is not a prime number because it is divisible by every non-zero integer. In other words, it has many factors. 1 is also not a prime number because it is divisible only by itself. 2 is the only even prime number. To test whether or not an odd number is a prime number, we test the divisibility by the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, etc. It helps to have a strong grasp of the multiplication tables when seeking out prime numbers and prime factorization. We identify whether or not an odd number is a prime number. We test the divisibility by the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, etc. For example, 121 is an odd number, but it is divisible by 11. Therefore, 121 is not a prime number. Composite number is a whole number other than 0 and 1, which is not a prime number. Here are the composite numbers: 4, 6, 8, 9, 10, 12, 14, 15, 16, etc. A composite number has more than two factors. The numbers 0 and 1 are neither prime nor composite. Prime factorization is to write a composite number as a product of prime numbers. We can factor a number into prime factors by using either of the following two methods: shortcut division and factor tree. I will demonstrate the shortcut division method. Prime factorization of 24. So we write down 24 and we write a upside down division sign. We note that 24 is an even number, so we should divide it by 2. So 2 goes into 2 one time, and 2 goes into 4 two times. 2 goes into 12 6 times, and 2 goes into 6 3 times. Now we have 24 broken down into prime numbers: 2 times 2 times 2 times 3, or 2 to the third power times 3. Find the prime factorization of 75. So we draw that upside down division sign, and we note that 7 plus 5 equals 12, which is divisible by 3, which means that 75 is divisible by 3. 3 goes into 7 two times, and 3 times 2 equals 6, and 7 minus 6 equals 1. So we carry the 1 in front of the 5 to make it 15. And we ask, how many times does 3 go into 15? And it's 5 times. So now we need to factor out 25. 5 goes into 25 5 times. And now we've factored out 75 to its prime factors: 3 times 5 times 5, or 3 times 5 squared. Find the prime factorization of 56. We draw out the upside down division sign. 56 is even, so we divide by 2. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1, so we carry the 1 in front of the 6 to make it 16. 2 goes into 16 8 times. Now we factor out 28, which is also an even number. We divide by 2. 2 goes into 2 1 time. 2 goes into 8 4 times. We get 14, which is also even. We divide 14 by 2. 2 goes into 14 7 times. And now we have 56 broken down into its prime factors, which is 2 times 2 times 2 times 7, or 2 to the third power times 7. Find the prime factorization of 384. We draw out the upside down division sign. 384 is even, so we first divide by 2. 2 goes into 3 1 time. 2 times 1 is 2, and 3 minus 2 is 1, so we carry that 1 in front of the 8 to make it 18. 2 goes into 18 9 times, and 2 goes into 4 2 times. 192 is also even, so we divide by 2. 2 goes into 19 9 times. 2 times 9 is 18. 19 minus 18 is 1. We carry the 1 in front of the 2 to make it 12. Now 2 goes into 12 6 times. 96 is also even. We divide by 2. 2 goes into 9 4 times. 2 times 4 is 8. 9 minus 8 is 1, so we carry the 1 in front of 6 to make it 16. Now 2 goes into 16 8 times. 48 is also even. We divide by 2. 2 goes into 4 2 times, and 2 goes into 8 4 times. 24 is even. We divide by 2. 2 goes into 2 1 time, and 2 goes into 4 2 times. 12 is even. We divide by 2. 2 goes into 12 6 times. 6 is also even. We divide by 2. And 2 goes into 6 3 times. Now we have factored out 384 into all its prime factors, and we find we have 1 2 3 4 5 6 7, 2 to the 7th power times 3. Find the prime factorization of 504. We draw out the upside down division sign. 504 is even, so we divide by 2. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. We carry the 1, make it a 10. 2 goes into 10 5 times, and 2 goes into 4 2 times. 252 is even. We divide by 2. 2 goes into 2 1 time. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. We carry the 1. 2 goes into 12 6 times. 126 is even. We divide by 2. 2 goes into 12 6 times, and 2 goes into 6 3 times. 63 is not even, so it's no longer divisible by 2. 6 plus 3 is 9, which is divisible by 3, so we divide 63 by 3. 3 goes into 6 2 times, and 3 goes into 3 1 time. 21 is also divisible by 3. 3 goes into 21 7 times. And now we have factored out 504 into its prime factors. We have 2 times 2 times 2 times, which is 2 to the third power, times 3 to the second power times 7. And now we discuss the most important part of any math lesson, which are the practice problems that you do to secure your skills. And as you can see, there are ample problems for you to practice on, how to find all the prime factors of each number. I suggest you do as many problems as you need in order to gain a firm grasp on these skill sets. These skills are very important to master in order to do fractions. And be sure to check your answers with the solutions in the back of the book to make sure you have done the problems correctly. I hope this video was useful for you. Thank you for joining me at Do the Math America.